Welcome to Space Terminal, the show where we sit down with founders defining the next frontier of space infrastructure. Today, I'm joined by Nick Orenstein, founder of Manifest Space. They're crystallizing the identity and coordination layer for every spacecraft in orbit. Our listeners are leaders, operators, officers, and partners building in space. Welcome, Nick.
Thanks, Suni. Great to be here.
Manifest Space is solving for orbital coordination. Nick, why this wedge and why now?
Well, now is a time that the space industry is scaling beyond, what's happened for decades around government missions and space science and exploration. And now there's really an industrial segment in space. And with that scale comes the need for infrastructure. We're really in a moment for infrastructure for a while. And we're really excited to build a key component of that infrastructure to help everyone.
Nick, who relies on this capability and what second order effects for coordination and mobility does Manifest unlock?
The companies that rely on space traffic coordination are ones that operate satellites in orbit. So our target is to work with the satellite manufacturers themselves, as well as the operators. Usually those are the same company, but sometimes they're not. And traffic coordination really affects everyone. It's a community issue. It's an ecosystem issue around the world. So it's not limited just here in the U.S. It's really a global effort, just like air traffic control and maritime traffic control. Space is a mode of transportation, and it's a global mode of transportation now, which is even more exciting than ever before. That companies from around the world are sending satellites to space, and those satellites need to coordinate with each other, and they need to coordinate with a traffic control system or coordination system that is a space-specific system. So the days are behind us where satellites could operate in the dark, not talking to anyone but themselves or their own mission control. We're really in a time that traffic coordination needs to happen for everyone's benefit. It's really a safety, reliability, risk reduction support.
So, speaking of risk reduction, walk me through the actual beacon. What's inside? What does it sense? And how does it broadcast?
Yeah, we're building a suite of products to provide onboard space situational awareness to satellites. We're starting with an optical beacon and then building upon that with a GPS-based radio transponder. The optical beacon is something we are focusing on first because it can get to the market quickly and still provide really important value to small sats, especially CubeSats. And so this optical beacon is red and green LED lights on 5 faces of a 1/3 of a U payload for a CubeSat. You can think of it like the red and green lights that you see on an airplane wing. If you look up at night and you see, planes that are basically having lighthouses on their wings that say, "Here I am, don't hit me." And that's what we're putting on satellites. And, we're starting with a form factor as small as we can make right now in a demonstration mission at 1/3 of a U. But really, ideally, this miniaturizes much, much smaller than that so that every satellite from CubeSat to large sat, just like every airplane has these beacons, satellites should have that too. So we start with that, and that's launching in a demonstration mission in October on SpaceX's Transporter-18 mission, where we're working with a CubeSat company named Blackwing to launch us. We're really excited to work with them. And then in parallel, we're developing out our GPS-based transponder, which provides additional capabilities. So the beacon, its focus is visibility. The transponder helps with position and identity. There's areas in which a beacon can also provide position and identity by getting information from the host satellite. And we'll be testing some of that in space. So, space technology, we should make some improvements over what's in aviation. And so with the beacon, for example, we won't just be blinking the red and green lights on and off steady like airplanes do. We'll be able to pulse modulate them akin to a Morse code situation, though it's not truly Morse code, but we can pulse out errors, codes and certain simple information so that even just from the beacon, a satellite operator could learn about the state of their spacecraft.
There are a slew of radio processing signals and sensors in the market. So, why haven't existing space companies or situational awareness companies solved for this already? And what do you guys do different?
They've solved for it in a bespoke way, sometimes in kind of internally developed solutions that help their companies, based on certain operations. What hasn't been developed yet is a standard ecosystem-wide coordination layer for space traffic coordination. That's what we're really excited to build, is something that helps everyone. It is a combination of hardware and data that supports the network effect and the ecosystem, but it also does the job for these other companies of traffic coordination services and the hardware development. It does take time and resources to build the hardware that we're doing, and so by doing it in a standardized way, we can offer everyone a seamless capability. So we're really excited by this because it's an infrastructure opportunity, and now's the time to do it. People haven't done it in the past because there weren't enough satellites for the risk of collision to be as high as it is now. There weren't transporter missions or more years ago, so now there's just more missions for small sats and CubeSats to get into space, and a lot of them are finding that it's hard to find their satellite, and we want to help prevent lost satellites so that everyone who launches to space can operate safely and reliably for as long as their mission needs to go on.
To summarize, you mentioned that the applications are pretty broad based. It's an ecosystem wide application, whether it's launch, reentry, satellite operations, for RPOD, for space domain awareness. But specifically to the case that you mentioned, could you just expand on why your customers wouldn't be able to find their spacecraft and how the beacon helps?
Yeah, there's a few areas within launch and early orbit phase where satellites tend to get lost, either temporarily or permanently. One is even in just the first moments after deployment, where the rocket second stage, for radio interference reasons, prevents satellites from turning on their radios for some amount of time. And so there's a custody gap between deployment and activation, which could be solved by turning on visible beacons that don't have radio frequency interferences. Then there are issues around actually communicating with those primary comms. If the satellite is deployed in a state that it doesn't turn on its attitude control, for example, and is tumbling, or the primary comm system doesn't have links, or it does burns and those burns underperform, and so the satellite doesn't pass over the ground systems ground stations, I'm sorry, that it expects to. So there's a number of ways where literally just finding the satellite is problematic. And so having beacons, which can be visible from the ground, from telescope systems that we're working with, as well as ideally SpaceX's Stargaze system, allows for visibility, which then can help identify the satellites to track them. The identity is also a challenge in these early parts of a mission where dozens of satellites are deployed at once these days from a single second stage. And it takes, we've heard, days at sometimes, maybe even longer, for the differentiation between satellite A, B, C, and D to be well understood within the catalog. So if you have a train of satellites all coming off of a transporter mission, and it takes a few days to know which one is yours to send your commands to, we can solve that in a matter of minutes or hours instead by having a beacon that says the license plate from space.
In a market where the base is currently tens of thousands of satellites, we're moving to a market with a million satellites in space. Your model scales with how many satellites can carry your hardware. How are you solving for adoption and distribution?
Yeah, for adoption and distribution, we look to early adopters first, like all startups, and then from there build into network effects that you were mentioning. The early adopters that we're talking to are the types of companies that are either on among their first launches, and so their risk tolerance is very low because they don't want to lose their satellites or company over a failed launch. We're talking to some small constellations, the kinds of companies that are sending tens of satellites or a hundred or so satellites in their, planning, because what we can offer is also capabilities to help them with management within their fleet of different coordination capabilities, including rendezvous and proximity operations. And then we're talking with some strategic partners where a win-win scenario would kind of make each of us, customers of each other. And so those are the kinds of ways to get this going. Like every startup, you have to start somewhere. And then along the way to the broader network effect, I've also already begun a large, for us, advocacy effort, to work with regulators around the world to step by step understand what does the community need, what are the standards that are in place right now from all of the work the space traffic management community has done for decades, and what are the standards that still need to be created, that there are gaps in capabilities that we can fill. So I've had involvement with the U.S. government. I'm on a industry group of industry advisors to the to the State Department as they work with the space situational awareness effort at the UN level. I met last summer in Japan with some of the cabinet office team for space, which is their version of Congress. I've met with our Congress staffers here in the US. And so that's kind of the middle piece, is that I do eventually think that regulations will require this, just as they do in aviation and they do in maritime. Our job at Manifest is to make sure that whatever does become regulated is something people want anyways. Like we're not out there to sell a tax to people. We want to build solutions that reduce risk, help add value around operations, improve awareness in space, that make rendezvous and all of these new the ISAM service assembly manufacturing capabilities possible at scale. And to do that in a way so that what we create in the commercial marketplace is what the governments then say, okay, this is the smart solution.
I like this line that you've written on LinkedIn, which is ADS-B is for aviation, AIS is for maritime, and Manifest Space is building the standards and protocols for space. So you share a very unique advantage being the builder as well as working on the advocacy effort with regulators. What is the challenge? Why are we unable to have, for instance, an AIS for space this year?
Yeah, I think the roadblocks are coming down, without much resistance. It just takes time. And they were put in place, unintentionally, almost just by the nature of where the industry was before now, where satellites did not have to necessarily coordinate very much with other satellite companies. But what I think going forward, that's one of the frictions is, there are some companies who have said it's a seatbelt problem. Once I'm told I have to wear my seatbelt, of course I'll wear my seatbelt. But until I'm told not to, in our example, I'm not going to fly your transponder until I have to. But that same person is saying what I'm building is valuable. They just don't want to have to buy it until they're told to buy it. Alternatively, we're finding customers who are interested early on. And so, we do see the business opportunities at the start. You know, roadblocks from a regulatory standpoint, I think that the regulators around the world right now are doing much smarter regulation than ever before in the space industry. And so they want to make sure that whatever gets regulated is viable to the industry, so that it's pulling, not pushing. And so that's where they are taking slowly this process, reasonably so. Some of it, getting a level into the weeds of it, is a question of which agencies regulate what. So the FCC has regulations over radio frequencies in the US, but there's also radio frequency regulation at a higher level with the ITU globally. Those challenges are beyond just the technical side of it, but are very much the geopolitical side of who has global authority over the regulations, independent of what they regulate. And then there's just a sense of these things take time at a multilateral level. And so, but we see that time frame being 5, 7 years, not 15 years. And I think also thanks to and the acronyms are horrible, but AIS in maritime and ADSB in aviation, those systems are so robust now that the industry and the regulators see, I believe, a value in creating that sooner rather than later with space. Those two systems existed after decades of other operations in maritime and aviation not working well. And ADSB cost billions and billions of dollars globally to put together too late. And so a big part of our advocacy effort is to make sure that everyone sees the value in doing things before it's too late. And we're just a piece of that. We are not ADSB for space. We're the onboard equipment that enables the full system to work robustly.
You alluded to earlier, you're flying your first beacon on the Transporter-18 with SpaceX in October. What will make this a success, and what exactly does the flight need to prove?
Yeah, a success for us would be positively observing the CubeSat, and the beacon. That's not really necessarily possible without our beacon to see a CubeSat from the ground or from SpaceX's Stargaze system, which is a relatively new system. So for us, there's different metrics of success, and we're going to have enough of those metrics that I'm confident we'll have a successful mission. But the real, bow around the present kind of success would be that telescopes on the ground would be able to see our beacons, and also Stargaze would be able to see the beacons.
What happens to the signal or the data that's collected? What gets processed on edge versus what is downlinked?
In this test, the downlink will be like demonstration test kind of pre-populated codes. But in fully operational scenarios, the telemetry will come either from the host spacecraft or from our own independent system. What we're building, in a modular way, the best product that we offer is one that is fully independent, where the GPS data, an IMU, power, and antennas are all independent, so that this device, like the aviation systems and maritime systems, is a backup emergency device. Um, though that data comes down to the ground, and a lot of it is processed by us and the operators. But really, in order to unlock automations and provide the best value at scale, the future is really for the transponders to do edge processing at the spacecraft, so that we're really bringing awareness to the spacecraft. The situational awareness is a broad concept, and mission controls around the world are tracking situational awareness and domain awareness. But what's not happening yet in a simplified, automated way is for the spacecraft themselves to have this awareness, and for it to lead to automations. So we're going to build that as well.
To clarify, that would be the second stage with the transponder.
Yeah. So, for example, the transponder knows where it is. It gets from the traffic system that we provide uplinked to the transponder where another satellite is. And the mission case is for those two satellites to rendezvous. It becomes like the instrument landing system of aviation, where those two vehicles can coordinate with each other using edge processing in space, and go from the other side of the planet to 10 meters away from each other, and then at 10 meters away from each other, their own specialized onboard rendezvous systems kick in.
I'm going to ask you for a quick rapid fire. You're going to rate these risks from 1 to 4. 4 is the highest risk. For your upcoming mission, atmospheric interference.
2, 1, it's real, but it won't be every day.
Precision pointing of the beacon.
2 or 3. We're putting the LEDs on 5 faces of the 6 faces of a CubeSat. So at least, to that last question, even if it's tumbling, we should be able to see one of those 5 faces.
Does that create interference or noisy data, or is it necessary for precision?
Because we have an IMU on it, we won't be beaconing from all five faces constantly. We'll have some smarts to it to make it not noisy.
Power dependency.
That risk is entirely on the host satellite. So
Right.
I'll punt that to no risk for me, but
Partner.
all the risk is on them.
Receiver infrastructure.
That got de-risked because we are now talking to a ground telescope company that's going to do great work for us. So I think that is, a one or a two. It's the same as the atmosphere. Like we will make it work.
Awesome. So, what am I missing from this list that's actually a four or maybe a five?
It is the reality of our first mission and the CubeSat provider's first mission, and we got to get a CubeSat that's working and get it out there, and but that's why with all of our experience, are building great hardware and we'll test it. Um, and uh, Other than that, we think the risks are fairly low because it's a fairly simple product.
Ground telescopes and ground infrastructure. Uh, Quite a lot of the existing infrastructure is legacy. Is that a gap for what you're building?
Yeah, it is a gap. The legacy infrastructure for traffic, awareness and coordination is ground radars. Uh, those are very expensive. They're not on every inch of the earth. And as we talk, especially with government users of ground radar, the burden to point those at anything in space is really high because they're intended for high value assets. And so, right now, if there's not that many high value assets, ground radars can be used to look for things. But when there's not, 100,000 satellites instead of 10,000 satellites, the ground infrastructure is just not going to be able to find everyone in a coordinated AIS and ADS-B level. It's the same as an air traffic controller in a tower at an airport. They have ground radars, but they're relying on the airplanes themselves to tell everyone where they are. And the ground radars are supplemental for a number of applications, and that'll stay true in space. But the big gap is that there's not a coordinated way for the satellites to all communicate their information. There's bespoke one-off ways and non-automated ways, and things are getting better. So I'm not saying these things don't exist at all. Obviously, there's amazing systems like TRAX now online, and NORAD has been tracking satellites for decades. So there are satellite tracks, but the future gap is around maneuvering satellites and servicing, assembly, manufacturing satellites and fleets of hundreds of satellite constellations. That kind of environment in LEO and MEO demands coordination, and that coordination layer is a big gap right now.
And what are your plans for growth? How do you see the base of Manifest Space growing? Is the focus only on fleets of satellites, or do you see expansion to other products, such as vehicles or other space objects?
Well, yeah, we start with the hardware and data services around like beacons and transponders, and those are applicable not just to spacecraft always in orbit, but also to reentry vehicles, so that reentry vehicles could communicate with ADS-B and AIS themselves. And so just expanding and growing to as many customers as possible. And then, without giving away too much of the secret sauce, but to excite people about the things where we want to manifest in space, we are then using those technologies modularly to build additional types of products. And those are related to optical and RF communications, and beyond, fundamentally so that space traffic coordination can extend beyond its current altitude limits, which, I say, and I think is reasonable, is where the GNSS satellites are. So even geo satellites have trouble getting GPS data. They really do rely on their own IMUs and on ground radars. GPS and the other GNSS satellites are in the, say 20 to 25,000 kilometer range of altitude. And as the industry and governments of the world move out to cislunar space and lunar space, there's big gaps in traffic awareness and situational awareness. And so some of what we want to build are solutions.
What supply challenges of today stymie manifest from capturing a quarter or more of the market in the near future?
The supply challenges are, I think, fairly understood and for us are just gated in development timing. And one of those is related to just the global effort that we're doing. And so, we're at least putting together plans right now for a scenario where we have a manufacturing footprint in possibly three different parts of the world so that from a supply chain, like speed and cost, it's easier to build closer to the customers, but then also from a regulatory export control perspective, I would not be surprised if there's eventually things where American customers would need to buy American parts, and similarly in Europe and similarly in Asia.
What's the cost to build and how do you make your model profitable?
I would rather directly talk to customers about that, but I would at least offer that the beacons, our target right now for the optical beacon is that the price to customer would be about $5,000. And so really as low as possible. And below what we've heard from some where there's a roughly $10,000 build versus buy threshold. So, we really want these beacons to be simple and below everyone's build it on their own threshold because it takes time and engineering resources and effort to do it yourself. And we wanted to do that job for people in an excellent way. The transponders, I think is something better to talk to customers about their needs and how independent of a system do they want. What types of encryptions do they want? What kinds of data services do they want? And so then, the target pricing is, you know, somewhere related to those value propositions.
You raised recently, congratulations. Talk to me about team. What makes your current lean team the right team to build space coordination? And are you looking to hire in the future? What are your plans on expansion?
Yeah, I'm really thrilled to be working with the team that we have. Currently, four co-founders are the group of us. Myself and two of my from many years ago homework buddies in astroengineering grad school. And as well as another person we've met along the way who's really a world class marketing officer who's built brand identities and campaigns for Fortune 500 companies, as well as agencies of his own through the years. So um, he's helping us on that side. From a why are we the right ones for what we're building? Just some of that is looking at the experiences that the three of us as engineers had previously at SpaceX. I was on the crew equipment team, which was part of spacesuits and mission operations, and built, among other things, the rescue beacons and rescue radios for astronauts, which I hope are never used, but if they ever have to be, would support rescue in an emergency landing scenario. So, in some sense, I built for SpaceX beacons and radios to find astronauts, and now it's time to build them to find satellites. So I had some experience in that with the regulatory side as well. Then from my co-founders who were at Hyperloop doing a number of vacuum systems engineering, tests and simulations, and NASA JPL, where our CTO spent a number of years doing satellite work for rendezvous and proximity operations, landers for Mars, with deep space communications needs. We're really just a team of engineers who has flown many things in space already. We're aware at a systems level of the needs of a full spacecraft. And we also have mission operations experience. So we know what the mission controllers, the real users of these systems, are needing.
What are some lessons you had to unlearn in your new role as an entrepreneur, as the founder of Manifest Space?
Yeah, it's a fun question that I'll answer it this way. At SpaceX, the internal, like, for in all everything integrated experience, as well as the extreme time commitment of being a SpaceXer, provides very little awareness of what's going on in the broader space industry. And so when starting Manifest and some of the work I did in the time in between SpaceX and Manifest, what I had to relearn was the ecosystem out there. I'm proud to have been a SpaceXer, and they do a lot and are doing more. SpaceX can't and won't do everything, and there's a global industry of space companies that are doing great things. And so learning about them, meeting them, and now hopefully helping them has been really rewarding.
You previously had experience working with venture funds. This time you raised from venture funds. What are some lessons you've learned, and what advice would you give to founders raising in today's market?
Yeah, you're referencing like back in at the beginning of my career, in the kind of 2008 era. Dates me a little bit of what kind of an economic crises our country's gone through.
We won't date
Um,
you.
yeah, I was working on a not space startup, and it didn't get investment, but I went to go work as an associate at one of the venture funds that had turned me down. So I spent a year or so on the venture side of the table, and learned a lot there. Some of the lessons that I learned there, I still apply now. Um, that well, one of the realities is that no matter how passionate an entrepreneur is about the 30-minute Zoom call pitch that they get with an investor, investors are inevitably getting 1,000 of those a month. And it is very hard to break through signal to noise ratio with even a warm intro to a Zoom call. And so the relationship building it takes to get to know the investors that end up investing in you it takes a lot of time. It takes a little bit of luck that you capitalize on, and it takes the ability to form relationship. It is more than just the first Zoom call, and so that's hard but challenging. And then I would also say there is, and this is, to me, a honesty that maybe investors don't like to hear, but there is a cycle to the calendar season. And inevitably, there are a lot of the times of the years where investors are not paying full attention to investing, whether that's for family or vacations or other conferences or who knows what reasons. But what I have found to be true for 20 years, and this is not a new post-pandemic thing, is that talking to investors about your ideas in January and February lead to deals in March and April and May. And then nothing really happens in the summer. And then in September, people talk about some things after Labor Day. And if you can get a deal done before Halloween, then you're lucky. And that's it. And do not try to start pitching people in November or December. And I made that mistake multiple times for multiple years, and it never works. And so just and that is so counter to the can't stop, won't stop, harder, better, faster, stronger mindset of an entrepreneur and a startup of
Right.
what do you mean I have to wait 3 months until I can start my pitches?
Right.
But be prepared to start a pitch in January and February, not in October or November, and figure out how to make that work for you.
Talk to me about after Transporter 18 in October. What should we be watching from Manifest over the next few months?
Yeah, and so the next few months after that is really for us just looking at the year of 2027, where the beacon itself will be able to go from a demo unit to on the market for sale. And so we think that could even happen fast enough for companies that are flying at the end of 27 to fly it. And then for our transponder, for us that we will have an equivalent demo mission in 2027 where we show the transponder working as well. So those are really the two milestones. They're technical and also go to market milestones.
And finally, Nick, how can satellite operators or launch providers contact you, contact Manifest Space?
The most easy way to do it is an email, hello@manifest.space. And we all read that, so that'll come to me. And then feel free, of course, to reach out to me on LinkedIn. Please follow us on LinkedIn, Manifest Space, where we post all about our company.
This has been Space Terminal. I'm Zuni from Imagining Forward. New episodes are out every week. You can find Nick Orenstein and Manifest Space in the show notes. You can also look up Manifest Space on our intelligence tool at imaginingforward.space. Thank you for joining, Nick. Really
Thanks,
appreciate it.
Zuni. This was fun. Appreciate it.